Thank you very much. Thank you for inviting me today. I'm very happy to be here and presenting about the project that we're working on at KDE. Just before I get started, can everyone see the slides?
Yes, we can see and hear you loud and clear.
Okay, great. Then I will be looking at the slides, so I won't be able to see if there's any comments or something in the chat. So please just speak up if I'm missing something that's happening in the Zoom meeting. So I will present today about Op Green, which is a new project from KDE Eco, and the power of FOSS to prevent e-waste. And there are several links in the slides to resources that might interest you after the talk. You can either go to our repository at the KDE GitLab instance in Vent, or you can scan this QR code. I will try to remember to come back to this at the very end of the talk. But before I get started, I think it's good to have everyone on the same page about what we mean when we talk about free software. And so just to get an idea of what is the power of free software, it's important to understand what exactly it is. And to do that, we need to talk about what source code is. So programmers write source code with a human readable programming language. I have an example here in the language C, which if you can look at the code there, you may not know how to write a program, but you can probably guess what this program does. I'll just let you look at it for a second and think about it. So if you guess that what it does is it prints hello world, you are correct. This is a command for the computer. So you can think of software as a recipe with commands for the computer. And when the code is human readable, when you have the source code, you can actually see what exactly is happening in a way that is understandable to regular people. This source code goes into what's called a compiler and translates that into a machine readable code. This is a binary. If you look here, it's just a bunch of ones and zeros. If you were to look at this and then ask someone, what does this software do? No one can answer that, right? So this machine readable code is perfect for computers, but terrible for humans. Now, when we talk about free software, and usually it's in comparison to proprietary software, what we mean is the licensing guarantees access to that source code, that human readable code, and you can do certain things with it. Whereas proprietary software, you only get access to the binary and you are restricted in what you can do with it. The term free actually doesn't have to do with price. It has to do with the user freedoms, which are to use, study, share, and improve the source code. Okay. So now that we're on the same page about what we mean by free and open source software, let's now talk about the power of free and open source software, or FOSS, to combat environmental harm. So the ICT sector, or the information and communications technology sector, currently contributes about 3% of global CO2 emissions. This is on a par with the aviation industry. And it's estimated that if nothing changes, it will be up to 30% of global CO2 emissions by 2050. The energy consumption is also very high. The International Energy Agency estimates that about 10% of the worldwide electricity consumption is from the ICT sector. And of that, when you look at the data centers, the networks, the end users, about half of it comes from just the manufacturing. And to illustrate that point, if you look at the carbon footprint by device, here you're comparing desktops to laptops to tablets, etc. You can see with the orange part of the bar plot that most 75 to 85% of the CO2 emissions over that device's lifespan comes from the production alone. So what I'm going to talk about today is the environmental harm of this linear model of the produce, use, dispose digital economy. And I'm going to talk about it in terms of where software meets hardware. So what we want, because of all that embodied carbon that goes into the manufacturing of a device, we want to interrupt that disposal stage, right? We want to keep those devices in use so that we don't have to then produce new ones and pollute the environment at a disposal site. And I want to talk about first with use. So we're going to go through all produce, use, and dispose. I'm going to start with use. We can talk about use in terms of the inefficiencies in computing, which is not necessarily an improvement in the functionality. And to illustrate this, can look at an example of the energy consumption of two software products. This is from the German Environment Agency, in which they compared various software products doing the same thing, called a usage scenario. They do the exact same thing and then measure the energy consumption to perform that task. And what they find, as you see here, in this particular comparison, they don't identify which software products they are, but they say it's an open source and a proprietary one. You can probably guess which products those are. The proprietary one consumes 4 times the energy. Okay. Now, for an individual user, this may not be that significant, but you have to think of this at scale. When you scale this up to billions of users, you're talking about a lot of energy consumption. To illustrate that point about how software inefficiencies scale up, this is an example from an online course from HPI, in which back of the envelope calculation looks at how much energy is consumed with a 1 CPU second increase in a process in a piece of software. Now, a 1 CPU second increase is about 10 watt seconds, which is not very much. But if you multiply that out by 1.5 million users, which also is not very much, and you assume that CPU second increase occurs 20 times a day for 230 working days, you're talking about the energy consumption of 19 megawatt hours. Now, to put that into perspective, that would be the equivalent of driving an electric vehicle from Paris to Shanghai round trip 6 times. Okay, this is for 1 CPU second increase. Now imagine 4 times the energy consumption of a software product across billions of users. You're talking about a lot of energy. It's also important to point out that the more the software demands on the hardware, which we're looking at here in terms of energy consumption, the more you're going to wear out that hardware, and it's going to be broken more quickly. When software is making our hardware break more quickly because it's demanding too much, or it's too bloated in order to keep using older devices, which may not be as powerful, we end up disposing our devices. This is a really big problem. In 2015, Achim Steiner from the United Nations Environmental Program referred to a tsunami of e-waste rolling out over the world, and it's only increased since then. The World Economic Forum talks about the digital e-waste as being the fastest growing waste stream in the world. Here's an illustration of the e-waste produced by a single British citizen in their lifetime. This is a statue called the Waste Electrical and Electronic Equipment Person. It represents 3.3 tons of electronic waste, which is a 7 meters tall statue that a single individual produces in 1 year. In their lifetime. In the best case scenario, these devices end up in a treatment center, for example, here in Ghana, where the devices are then broken apart and the metals are extracted. This is a picture of what are called burners. This is where the cables with the insulation around them are burned off to get the metals inside out. This is, again, best case scenario is toxic to the air and the land and the people treating these devices. And the worst case scenario, it actually is causing death in animals and the people living there. Okay, so e-waste is a problem. Production is a problem, as we already mentioned earlier. There's a disproportionate impact of the environmental harm in terms of carbon emissions in the production. In fact, they are so high that another German Environment Agency study found that even with a 10% increase in the energy efficiency of a new device, replacing the older notebook, the older laptop, can only be justified after 33 to 89 years. Okay. And it also comes with huge social costs, including human rights violations. So the production of devices require rare earth minerals that are often mined in non-democratic countries. Here we have a picture of a cobalt mine in the Congo with child labor. Okay. So every time your device is thrown away prematurely, if it still works, for example, then you are contributing to the waste in the e-waste issue, and you are then contributing to the production of new devices with all the costs that come with that. Okay, so now let's talk about the critical role that software plays in this. So software design is fundamental for how long you can use a device. Software that becomes bloated or has feature creep where new and more features are added may then require more and more powerful devices to meet the minimum system requirements. There's also the problem of planned obsolescence, that is where software support ends. This then can render a new device or a functioning device unusable. It can increase the energy consumption where you're adding more and more features that may not even be wanted by the user. Devices get discarded and then new devices are produced and shipped unnecessarily. If we go back to the example here of the bloatware and feature creep increasing energy consumption, comparing these two software products, here are the word processors. If we look at actually the energy consumption over time, this is from a presentation at the CCC, the Chaos Communication Congress in 2019. And these are the same two word processors. The top one is the open source software, and the bottom one is the proprietary software. And what you can see here, if you look at that blue line, this is looking at what happens over time in terms of the energy consumption. The blue line represents when the document is saved. You can see, for example, in the open source software, there's a spike in energy consumption where the processor is doing something, and then the software goes idle. The proprietary software product, by comparison, continues doing things in the background. Now, what it's exactly doing, it's not said in this report, but it's easy to imagine this is probably some form of telemetry that is sending information back to the company. This is consuming energy in the background, and it may be for a feature that actually users do not want. An example of features users do not want, increasing the energy consumption. This is a study for the EU in which they looked at the energy consumption from ads and tracking that European citizens would turn off if they could. About 60% of respondents said they would stop advertisements on their smartphones if they were able to. And they looked at how much energy consumed. Great. Can you see the screen?
Yes.
Great. Okay. I will quickly try to get through to wrap up so we have some time to hopefully have some questions. So abandonware will then drive e-waste. Consumers are aware of this problem. This is a study in Europe looking at reasons for purchasing a new device. 30% identify performance of the old device had significantly deteriorated, and 19% identify that certain applications stopped working. This is very likely a result of unsupported software, and then slowly the devices becoming unusable, or feature creep and bloatware causing the old devices to then not function properly. Free software is a solution, and the reason for that is because it enables the longer use, reuse, and recycling of software and hardware. Whereas proprietary software, at all of those stages where you can interrupt this disposal stage, you have a vendor dependency in order to be able to do those things. So let's look at a concrete example of upcycling or reuse of hardware. On the 14th of October, 2025, Windows 10 will end support, or Microsoft will end support for Windows 10. And this is estimated to create e-waste out of 240 million devices, which cannot upgrade to Windows 11. This is a software decision. There's nothing about the hardware that requires that. The energy consumption and hardware demands of the Windows 11 will increase. For example, there's now no option to opt out of the ads shown in your start menu, which are only going to increase the energy demands and how powerful the hardware is. 14th of October, which is the end of support for Windows 10, is also ironically International E-Waste Day. From the We Forum, the same initiative behind that We statue that we saw earlier. And it is KDE's 29th birthday. So the stars are aligned, and we want to run a campaign to raise awareness about the issue of e-waste driven by software, as well as support users in upcycling their devices to a free and open source software operating system to keep those devices in use until the hardware stops working, not the software. If you are interested in the topic, everyone is invited to get involved. We want to get not just technology organizations, but also environmental organizations involved in raising awareness. We have here's an invent repository in order to discuss and plan the campaign. We have materials that we've designed to distribute to end users to raise awareness about how software can drive e-waste and how free and open source software is able to combat that. If you want to get involved, we always need people to help with translation, designing new materials, etc. We are working right now on a user-friendly migration tool that users can install on their Windows machine and get help deciding which Linux distribution is the best for them. We are organizing workshops to help new users within this project and trying to encourage other people who might be interested in this topic to organize workshops themselves. But there already exists many workshops where you can do upcycling with software. There are networks of repair cafes around the world. We are building up an inventory of that so we can add it to the website so that users can find a support network to help them migrate to Linux. And then if you're a software developer, you can measure the energy consumption of your software and report about how it's sustainable. We are proud at KDE that we have eco-certified Ocular, our PDF reader, with the Blue Angel Eco label, the oldest environmental label in the world, and the official environmental label of the German government. We have written a handbook about this. The first 2 chapters are written for a general audience. So if you're interested in the topic of sustainable software, this is a good resource. You're all welcome to download it from our website. I'm going to skip over this. The topic that I'm presenting here, hopefully we'll do what we can as software developers to do things that are good for the environment. It's good for penguins, both literally, if we can help reduce the carbon footprint of the ICT sector. But penguins are also the symbol of Linux, so it's also good in a figurative sense. Just a note that this project is funded by the German Environment Agency. And yes, so I hope we have some time for questions. I'm going to come back to the Zoom meeting.